So 1.6 trig functions. So the other thing with the trig stuff is we aren't going to like redo the unit circle at some point. Probably not like early in the year, but there will be another time that we deal with like trig stuff when we get to like the derivatives of trig functions and stuff like that, where you'll be like solving them, where I may give you like a unit circle quiz just to like make sure that you know it, because I don't reteach it because at this point you've done it twice and I know that you knew it. So, but just like I would just make sure that like you look back and like refresh on that as well if you don't remember it, because on the AP exam like they won't give you one and they expect that you know those values. But anyways, so the first problems here, get to the correct page. They give you basically an angle, a radius, and an arc length, and you're solving for one of those pieces. So that formula is S equals R theta, and theta has to be in radians. So in number 2, they give us the angle is 175 degrees, and then they want us to find the radius value, and then the arc length is 10. So I chose this one so that way we can just do a quick refresher on the conversions. So if we have degrees to radians, you remember what my conversion factor is?
Is it 180?
Yeah. Pi over 180. So, well, and obviously it could be 180 over pi if we were going radians to degrees, but pi over 180 since I'm trying to go to radians. And so that ends up being I know I can take a 5 out of everything. Let me see. Oops. 35 pi over 36. Now, that is if you want to leave it in terms of pi. If you want to go ahead and actually like figure out what the number is, like the 35 pi divided by 36 would be 3.05 for theta. You can use that too, it doesn't matter. And so then I'm trying to solve for r, so r would be equal to s divided by theta, which would be 10 over, I'll just use the decimal number, 3.05. That gives me 3.27. And let me see, did they give us units? They didn't give any kind of units, so we can just leave it like that then for it. There's not really anything I would say in like calculus that we directly use this for, but just I would say probably 95% of the problems that we deal with in calculus that are trig are going to need to be in radians or are going to be in radians. So if they're not in radians, most of the time you need to convert them. So that's where with physics it's going to be opposite, because physics everything's going to be in degrees. Mm-hmm. So you'll just have to watch your calculator mode when we start getting into more of that like later on. But okay. Yeah, most of the time in calculus they're going to want it in radians because it's like a more, I guess, like comprehensible number, which like, I mean, I think degrees are easier, but for like what you're actually doing, they typically are going to do things in radians. But they'll specify if it's not, like if you need it in degrees, it'll specify. So did your notes remind you of which trig functions were even and odd? I I think they did.
I didn't write notes for 1.6, so I don't know.
Oh, okay. That's fine. So just as a refresher, again, not that it comes up a ton, but if it could when we get to like stuff of dealing with like symmetry and all of that. Cosine and secant are even. And then sine, cosecant, tangent, and cotangent are odd. It's not like super relevant for the problems. There's literally 4 questions that ask, say if this trig function's even or odd. Like it literally is just tangent. Like it doesn't.
Yeah.
It's not like an actual problem that you're trying to figure out. So anyways, just as a refresher there for you on that. But find all the trig functions of theta with the given conditions, which I know we did a ton of last year. Tangent of theta is equal to -1. Sine of theta is less than 0. So this is kind of like their way of making this like a little bit more difficult, is like they're going to give you like what a trig function's equal to, and then in terms of another trig function, that's how they're going to tell you like where it is. So this means that sine has to be negative. So that means that it's occurring at the bottom. So then I need to think, okay, well, where is tangent negative? In which quadrant?
2 and 4.
Yep, 2 and 4. So basically, I know that tangent either has to be here or here. And I know, though, that this is less than 0. So that means I have to be down here in quadrant 4 for this one. Because sine is negative. So I'm going to basically just draw my little triangle here like normal. So the tangent is y over x. So basically, obviously, it's just 1, but it's like 1 over 1. And something is negative. But I've already determined that the y value has to be negative. So this is a -1 here. Since it's 1, it has to also be 1 here on the x value. And then I need my hypotenuse value, which you can either use the Pythagorean theorem, recognize this as a special triangle, 45, 45, 90, and so it would be 1, 1, root 2. You could probably also figure it out with the unit circle, but I would say knowing that it's a special triangle is probably the easiest way to remember it. So then we just need to find basically all the trig functions for this.
How come the x has to be a 1?
Because this is just 1. It would be whatever the denominator is.
Oh, okay.
But the negative could have gone on the bottom. So that's the only thing we had to determine. But because it said that it was basically, we know that sine had to be less than 0. We knew that the y value had to be. Because they also could have told us that tangent was, well, never mind. Yeah. I was going to say tangent could have been positive and sine have been negative, and then both values, x and y, would be negative, but that would put it in quadrant 3. So we know that tangent is -1, which means that cotangent also has to be the same thing. I mean, it's flipped, but we're not writing 1 over 1. And then cosecant and secant. So what would the sine of theta be?
-1. Oh wait, no, opposite. It would be -1 over root 2.
Yeah. And then just rationalize it. So -√2 over 2. And this is where with this one, again, you could kind of just think about your unit circle because these are all going to be unit circle values because of tangent being -1. But as far as like actually finding them, yes. What about cosine?
It'd just be √2/2.
Yeah. And then over here, cosecant, we just need a flip sign, so it'll just be -√2. And then secant would be +√2. Let's see.
Would secant be 2√2/2?
Well, yes, but it would then reduce the two top. Because technically cosine started out over here as 1/√2, and then you just rationalized it right away. So,
Yeah.
but yes, if you flipped this, then it would, and you'd just reduce it. So, this is the only reason I normally write what it is originally, but I say that a lot of times I do just jump straight to here, especially if it's something that I know. It's just if it gives me weird numbers, then I'll write the initial thing so that I can like visualize it. But if you don't do that and you use the rationalized one, all you have to do is reduce it when you're done. So
Yeah. I think if I had written it out, it's
yeah. Let's see. There are some like trig graphs in here, but we did so much of that last year, and you don't really have to like just straight up graph trig functions in calculus. You'd be like using them for things. We're gonna skip that for now, and if we end up needing it later on for something, we'll just talk about it then. But pretty much all you would need is sine and cosine for anything that we would be doing, much like last year, like when you got to the AP exam, it was pretty much only sine and cosine they really cared about. It's kind of the same thing with calculus. So give the measure of the angle in radians and degrees, give the exact value of the answer whenever possible. So basically, if they give you a value that's on the unit circle, you should give the exact answer like from the unit circle. If they give you something that like is just like a decimal number that you like wouldn't know, you'll just use your calculator and give the answer in degrees and radians, basically. So 28 is the inverse sine of -√2/2. So the other thing to remember, which this isn't in the notes, but sine occurs, inverse sine, I should say, and inverse tangent occur on the right side of the graph. So if we were looking at our circle, they would be over here in this area from -π/2 to π/2. And then the inverse cosine is on top. If I can draw a straight line, that'd be great. From 0 to pi. So just to be mindful of that when we do this. So if we were looking at, I'm going to grab a unit circle just to put up there really quick since it's been a little bit. Maybe. So if we were looking at this, I'm looking for where sine on the right side is -2 or -√2/2. So sine is the y, so that means it would be down here. But remember, the common mistake is people saying it's 7π/4. It would actually just be -π/4.
Yeah.
Because it's from -π/2 to π/2. So this would be at -π/4, or in degrees, -45 degrees. Like that. Are you okay with typing them in and changing the mode on your calculator and all that?
Yeah.
Okay. I won't do one of those ones then. But yeah, if it's a value that you would know, or like even one of the problems is the inverse sine of 0.5, obviously that's just 1/2. That's a value that you would like know. But there's another one that's like, you know, -5 or like 0.8 or something like that. Like we don't know those. I mean, obviously 0.8 is close to the 0.866, which is one of the values if you look at it as a decimal, but it's still not going to be exact. So you just use your calculator on those ones. 38, they want us to find the exact value of the 6 trig functions for the angle theta. And so they give us theta is equal to the inverse tangent of -5/12. So basically we need to set this up as a graph. So we know that inverse tangent is on the right hand side, and we know that tangent is negative in quadrant 4. So that tells me that with all of that information that I have to be down here like I was on the first one I did. And so then we've got y over x, but the negative sign can go on either. So the y is down here, so that means that my 5 is negative because the y value needs to be negative. And so then we've got x is 12. Do you know what the hypotenuse is? This is a Pythagorean triple.
No, I'd have to do
Okay. So it would be 13 because 12 squared is 144 and 5 squared is 25, so it'd be 169. So it would be
that.
13. So 5, 12, 13 is a Pythagorean triple, just like a 3, 4, 5. Those are like the most common ones. There are obviously others, but the ones that we end up using a lot. And so then we just need to find the 6 trig functions based on that. And obviously, this is what gave us the information. I mean, tangent is still going to be -5/12. But obviously, it was just the inverse that they gave us. So it is obviously needed to be rewritten. So sine of theta is -5/13. Cosine of theta is 12/13. And then on the other side, we just need to flip the fraction. So cosecant -13/5, secant 13/12, and cotangent -12/5. So it's like the same stuff we did last year. They're just kind of presenting it a different way, pretty much. The last thing is basically you would just need your calculator to do it. So 42 is the tangent of the inverse sine of 9/13. And they want to know what that is equal to. They are giving the answer in radians, but they do not specify. It has to be in radians based on what they've given us. Which I'm in degree mode, so I need to fix that. So then obviously just do the tangent of the inverse sine of 9/13. And we would get 0.959. And that's all you have to do on one of those ones. So it's pretty chill, I would say, on that. All right. Any questions on any of that? All right, so problems 3, 9, make sure. 27, 37, and 41.